In this second video for Chapter 12, I want to cover some topics that you saw on Mastering Chemistry problems, but I did not talk about in the lecture videos. And the first one is just the different types of phase changes that we see in the world around us. And so, note all these names over here, okay, fine. And I'll talk more about endothermic and exothermic a little bit in just a second. First off, let me just use something like water as an example. Let's take solid water, right? Ice. What do I have to do to get it to melt? I have to add heat to the sample, and that takes us to the liquid state. Okay, so if I add heat, well, that's an endothermic process. Where is this on the diagram over here? Let's just label it as 1. What does it mean to go from a solid to liquid? Solid to liquid, that is melting. So there's 1. So basically, as you're going up on this graph here, it's an endothermic process. So notice the reverse process here, 1 in green, and that is exothermic. It releases heat. If we continue on with what we started, if we keep adding more heat, then this is where we would finally boil away the water. So we can convert everything into a gaseous state. And again, it's still endothermic, right? Second one up, 2, vaporization. And then if we want to go the other way, release of heat, exothermic, and that would be condensation. And I use this as, an example of, what we're familiar with. For the other ones over here, sublimation and deposition, I'll just use one that we saw in lab. If you heat up solid iodine, it can go to the gas state, right? And this is known as sublimation. And then the exothermic process here is deposition. So basically here, just, know the different names of the phase changes and then whether they're endothermic or exothermic. Now these changes can also be shown in something called a heating curve. And this is just a heating curve for water. Right? Down here, ice, well that's right, H2O solid, liquid water, H2O liquid, and then steam, H2O gas. So we're basically on, the same pathway that we see here. It's just plotted a little bit differently. Now the actual phase changes are occurring right there and right there. So whenever you get a phase change occurring, there's actually a plateau in the temperature of the sample. So like when water's boiling on the stove, at the very beginning of the boiling process, it's 100 degrees. At the very end of the boiling process, it's 100 degrees. That boiling water doesn't get any hotter than 100 degrees. The steam can get hotter, but the liquid portion itself can only stay at about 100 degrees, and that's it. And you see this is plateau process, or there's observation of a plateau in these curves. In between, then basically your physical state is just warming up as you go, as you're adding heat to the system. But again, just appreciation that, right, these heating curves are, again, basically just describing the phase changes like that we're talking about here. It's just that now, right, there's actually a temperature associated with each phase change. And the last concept that I want to talk about here for the second video is vapor pressure. So vapor pressure, one thing, it's associated with a pure sample. And what it is, it's the pressure that forms above the liquid state of the sample. That pressure is a function of how many molecules that are in the gas state here. It is temperature dependent, meaning as you increase the temperature, the vapor pressure increases. Remember, the vapor pressure so if that pressure is due to the molecules, it's in the gas state there, as the temperature increases, then more molecules should be forced in the gas state. And so your vapor pressure should increase. So you could say vapor pressure increases as temperature increases. The trend is opposite for intermolecular forces. As the molecule, remember we talked about intermolecular forces as a measure of like stickiness between the molecules. Well, if the molecules are really sticky, then in the liquid state, there's not going to be a lot of molecules going in the gas state, and so then we should expect a reduction in the vapor pressure. So these are not proportional to each other. One increases as the other decreases. Now again, for this class, we're not using the topic for anything. It's just a conceptual thing to know about. I think that's enough for the second video. The third video, we'll do some problems associated with this chapter.